Hey everybody, so we're going to jump into the iris data set. Before we do that, I felt like it was important that we start looking a little bit more at some data structures inside of Python that you're going to need to know about as we start using data. So let's go ahead. We're going to do this with Anaconda and actually a Jupyter Notebook. So if you can start up Anaconda and then fire up a Jupyter Notebook. And over here on the side, just select New Python 3. And you can go ahead and do File Save As and save this. Otherwise, it'll save as Untitled 8. You see it up here. I'm using this because it's an interactive environment that we can really quickly go through and just demonstrate some concepts. So we're going to start with something called a list in Python. So most programming languages have the concept of an array. And Python actually has arrays, but not maybe in the way that you might think about them. And there's actually third-party libraries that we're going to learn about that provide us with really rich types of arrays that are ideal for working with data sets like the iris data set. So today what we're going to learn about is just simply the basic list structure, tuple structure, and dictionaries in Python. We're going to look at those three things, and then we'll look at how to manipulate those to modify data in them, and we'll also look at something called a Python comprehension, which is a really cool feature. Now, Python is built to manipulate and process data, and so you'll see some nice features in using lists and dictionaries that you might not find in other languages. And so let's just start by creating a list. And the way we do this is we simply say the name of the list, and we use the assignment operator. And then inside of square brackets, we put the items in the list separated by commas. Now, one thing about Python lists, as opposed to other languages, that Python allows you to have different types. Don't do that. Let's do XYZ. Different types in your list. So some languages require that all the elements of the list be the same type. Python doesn't do that. It doesn't care. You can put anything in a list that you want, including another list, actually, which we'll look at in a little while. Okay, so there's our list, and if I just type a list in Python, it'll display the contents. So we run this, and sure enough, there it is. It says that it has everything just as we typed in or initialized it with. Let's show another list here real quick. Now, Anaconda, sorry, Jupyter Notebook knows about a list. So if I type a list again anywhere down below in a subsequent cell, you'll see that. And so on this one, let's just do F and 6 and 5 or something like that. And let's just print out what that looks like. Now, to work with Jupyter Notebooks, you can jump back up here at the top, just highlight and hit Run again. You can also come up here under Kernel and select Restart and Clear Output, and it will clear all the output for you and start over. You see the output here. So let's concatenate the two lists together. Now, I'm not going to assign the result of this to another list. You could do that. I'm just going to do the concatenation operation. So this isn't going to add the values in the list together. It's going to actually append this list with this list. So let's see what happens when we run that. And you'll see, sure enough, it did that. You see, here's the first list. And you'll see the result is a list. So if you needed to concatenate two lists together, it's very, very easy to do. The next thing we need to do is talk about slicing. Now, we didn't go over this much with strings, but these same rules apply for slicing strings. So often you want to get parts of a list or a section of a list out. And so, for example, if I said a list, square bracket, colon, -1, that's saying give me everything but the last item in the list. Now remember, a list is this one up here that looks like this. So this was a concatenation of the two, but we didn't change A list itself. So it still looks like this. And so if we say everything but the last one, then what we would expect to see is a list that only had these elements in it. So let's go ahead and run and see if that's what we get. And sure enough, that's what we get. It doesn't include the last one. If I change that to -2, let's see what happens. And you'll see it gets everything but the last two elements in the list. So again, very useful when you're just manipulating data and wanting to work with it. Now you can access an item in the list by simply giving the index of the list. So indexes in lists, just like strings, start with 0. So this is the 0th element. This is the first element, the 1 element, the 2 element, the 3 element. So if I say A list 1, it's going to print out the value 5. Also, we can just do a general slicing from the right, like this. So what that says is go find the second to the last element. So sometimes you just always want the second to the last element for some reason, or the third to the last, or the last one. You can do that in this manner. Okay, let's slice a range. If we do this, this will give us everything to the right, starting at index 1. And so our list starts, our index 1 would be 5, so it says give me everything starting with index 1. So you can grab things from the right, grab things from the left. So slicing is very powerful, and again, you can do that with regular strings as well. All right, let's move on. This is a really, really cool feature of Python, and that's replicating lists. We can actually say a list times 5. It will actually replicate the list 5 times, and it will return a list. So it's as if you concatenated a list to itself 5 times. And so you can see that's what it did. Really convenient way to just pound a lot of data in there really quick if you need to do that for some reason. Now, how do we add something to the end of our list? Let's go ahead and just, as a reminder, see what our list looks like. We can say a list dot append, and then we give a value. And we run that, and then we can say a list again just to display the value. So now a list has a 9 at the end of it. How about if you want to remove an item? So you can remove an item by del for delete, and then give the index that you want to remove. So let's say we wanted to remove this 6 right here. So that would be index 2. And again, a list. And now you can see that the 6 is gone now. Okay. All right, let's build another list called CList, and let's just put letters in it. So let's put D, X, L, and maybe an A. And let's display that list. So there's our list. Let's assign to CList multiplied by 3. So again, we've used that data replication feature, and now we've got a whole bunch of values in here. And then finally, we can say CList dot sort paren. And then type out what CList is, and you'll notice what it does is the CList.sort actually changes the order of the values in the list and sorts them alphanumerically. So that's a really cool feature. You'll notice these are all very, very fast functions. Okay, so let's do dlist as a list of lists. Now the way we declare a list of lists is like this. So 1, 2, 3. So that's our first list we want to store in our list. And then 4, 5, 6. And finally, you guessed it, 6 or 7, 8, 9. And then we can say, what does that look like? So let's run that. And you can see it's a list of lists. Okay. And to reference a particular element in this list, if we say dlist sub 0, which should get the first list out of the list of lists, that gets us the first one. And if we changed it to a 1, it'd get us the second one. And if we say dlist sub 1 sub 2, it's going to go to the first index 1 of the list of lists, which is this list. And then inside of that, it's going to go to index 2, 0, 1, 2, which should be the number 6. And sure enough, that's what it is. So this starts giving you a way to build and store matrix data. And if you remember the iris data set, you might start thinking, well, we could store that data as a list of lists in Python. And yeah, you could, but there's some easier ways to do that. All right, let's go on to dictionaries. So what is a dictionary? A dictionary is key value pairs. And by key value pairs, I mean something like this. And this isn't valid Python. I'm just trying to kind of show you an example of what we mean when we say key value pairs. So the key is the first element. So in other words, if I want to find the value at key A, I can just say A and it will give me that value. So it's key value pairs. So I can use this, you can think of this as like a dictionary. You're putting in a value and it's giving you back, or you're putting in a key and it's giving you back a value. So A, B, you can have anything you want as the key, right? You could have a number in here, it doesn't matter. And so let's look at how we declare a dictionary. Okay, again, key value pairs. So a dictionary is going to be equal to, now the syntax is a little bit different on this. It's the curly braces, and you say the key colon value, comma, key colon value, comma, key colon value. Okay, so we have 3 keys, 3, 4, and 1. And the value for 3 is a 1, the value for 4 is a 5. And this may seem a little confusing, but let's just go ahead and try it out. That's the way we learn, is by actually doing. And so there you'll see the actual dictionary. And so let's do another one. Let's do B dictionary. And let's make it have something that looks maybe a little bit more like you might expect to see. J. Let's say that is John, and let's see, let's fix this curly braces, right? And let's say that, oops, S is Sam, and let's do M is Milton. Okay, something like that. And then what does B dictionary look like? And then if we want to access something, it's really easy. So I've got 2 dictionaries now. I've loaded up 2 dictionaries. So a dictionary. And now, instead of providing an index, what we're providing is the key. So if I say a dictionary 4, then it should know that we're talking about this element, and it should return that value. So let's get down here to where we're at, and sure enough, it does that. And then B dictionary J. That should return the first name in our list. So we run that, and sure enough, it does that. So dictionaries are very useful as well. Tuples, basically immutable lists. Okay, so immutable meaning they can't change. These are useful when you're trying to set up values that you're going to use over and over again in the program that don't change. So here's how you declare them. My tuple equals, and in this one we just put it inside curly braces, and we can have, again, things of different types. And we run this, there it is, and if we say like that, so again, it's a list, but it's a list that can't be changed. So all the rules about how you index into it are the same. Here's what you can't do, though, because it is immutable, or we can't change it. We can't say we shouldn't be able to do this. We'll say, and it comes back and it says no, you can't do that. All right. The type command is useful sometimes because you get in the middle of things and you may not know what type you're dealing with for the particular object that you're dealing with. So if we print the type of any of these that we've been working with, like a dictionary, again, the print statement, it says, yeah, that's a dictionary, and then let's put in a list in here. This is showing you that Jupyter Notebook's remembering all that. So there's the 3 types that we've dealt with. So we've talked about those, all 3 of those. Those are basic things that are in Python, built into Python. You didn't have to pull in a library, you'll notice. We didn't have to import anything here at the top to do all of this type of data manipulation with these particular data structures. So we've learned about those 3. Now, comprehensions. So comprehensions. Sorry for the pop-ups. So these are easy ways to I'm going to delete this one right here. So let's delete this cell. Let's get back kind of through this, run. And, okay, so that's a comment. Okay, so comprehensions work like this. It's an easy way to create or modify data in lists. So let's look at a different way to create data in a list. So sum list equals, and we say x for x in range 6, as an example. So that is a comprehension. So what that says is iterate through 6 times. Iterate through this. And let's just see what it does. So iterate through this 6 times, starting at 0. That's what range 6 says. And for each time, give me the item and store that in the list. So you can see that this is how we can very quickly create a bunch of data. Okay, and we could have let's do this. Let's do an alpha list, and we'll just assign some letters to this real quick. So A, B, C, D, oops, D, just a comma there. And let's just print out what alpha list is. So go ahead and run that. So there's our list, and then let's do an alpha dictionary, and we're going to use a comprehension to populate the dictionary. Okay, so in this case, because the comprehension is going against the dictionary, we do curly braces instead of square brackets, and we do something like this. We say for x in range 4, because we know that we have 4 of these elements. Okay, and run this again. So what it did is it iterated through the so it went 0, 1, 2, 3, 0, 1, 2, 3. That's what this did. The for x in range 4. So x the first time through. This is like a looping structure if you haven't kind of got that already. So the first time through, x was a 0. So then what do we say? We say put a 0 here because that's what x's value is. And then as the value, go grab out of this alpha list the element that's at the 0th element, which is this one here. So here's a quick way to build a dictionary. Okay. And finally, we'll do one more real quick. And this one you may not really use too much, but we'll just do it anyway. This is going to be a tuple comprehension. And let's just print that to see what we got. So we're doing a dictionary, but the key is made up of a tuple. You see what we did there? So this is the thing that goes on the left side of the colon, and then the value is whatever x is when we iterate through. Okay, and so you could use that like this. You could say print, give me the value with this tuple. So in other words, it's using this key to do the lookup because it's a dictionary. So it should be printing out the number 1. Okay, so, and sure enough, that's how it does it. So you can start kind of imagining that this gives you a lot of flexibility in how to build up data structures and populate data. Now we have our iris data set sitting out there. We're going to essentially take it as a CSV file and load it. Before we do that, we need to understand a little bit more about the type of data structure that we're going to load into. And I felt it was important to kind of go back through arrays in more detail because you'll use them all over the place in Python. And so we'll talk more about the array data structure that we're going to use to load the data into. We also wanted to cover lists, dictionaries, and tuples, which we've done in this section. So I hope that was useful for you. Please keep watching. We'll be getting that iris data set loaded here in the next few videos. Thanks.